so welcome to Sweet Treats, Confectionery Science and Technology. I am with the Center for Excellence in Education. If you've joined us before, this will be very familiar to you. We were founded in 1983 by Joanne DeGennaro and Admiral Rickover, father of the nuclear navy and civilian uses of nuclear power. And our mission is to nurture high school and university scholars to careers of excellence in STEM. We offer 3 programs to teachers and students in the United States. The first up is the Research Science Institute, which is a 6-week summer program hosted in partnership with MIT. We also have the USA Bio-Olympiad, which my colleague on tonight, Michelle, runs, which is the nation's largest biology and education and testing program. And lastly, the Teacher Enrichment Program, which is the program I run. And I work to put on cool events like this. Non-pandemic times, I travel around, and my goal is to try to connect STEM teachers with STEM professionals, so they can see how STEM works in the real world. And so we can hop right into it. I am super excited today to have Felice, who is the Director of North American Continuous Improvement at the Hershey Company, and Hans Geyer, who is a Senior Commodity Technical Manager, also with the Hershey Company. And with that, Lou, you can take it away.
Okay, well, good evening, everyone. It's nice to be with you this evening to talk about STEM careers at the Hershey Company. So this is the agenda. We're going to talk about really focus on STEM careers at Hershey, and a little bit about STEM and students. But first we have to start with a question. So Hershey's annual milk chocolate production requires the equivalent of a full week of milk output from how many cows? Does anyone want to take a guess as to how many cows? Okay, we have 500. We've got 10,000. Your guesses need to go up a lot higher. Okay, 2 million. Anyone else? More than one. There we go. All right, let's see what the answer is here. It's 900,000 cows, or 2 times the total cow population of Switzerland. So someone said 1 million, so that was pretty close. That's pretty good. You should congratulate yourself. If we were live, you'd have a candy bar now, but we'll have to wait till the next live session. So my name's Lou Felice. I'm director of the North America Continuous Improvement team at Hershey. I do have a BS chemical engineering degree from Drexel, and I am a licensed professional engineer. And I've been working at Hershey for 34 years, and I've worked in most of the technical functions that exist in the Hershey Company. And I just love Hershey. It's a great place to work. It's a great town. If you have the opportunity to visit, I highly recommend it. So STEM careers at Hershey primarily fall into one of these groups or functions. So we have research and development, process design. You see a lot of process in the functions, process optimization. Then there's plant engineering and project management. And I'll just spend a little bit of time talking about each of those. So new product development or new technology development typically has individuals with these following degrees: engineering, materials science, or packaging science. There is such a degree. Very few schools have it. RIT and Michigan State and Clemson are the top 3. Not material science, but one that specializes in packaging materials. Food science, chemistry, microbiology, and biology. And the type of work that they do is product innovation, product characterization. We have sensory science, nutrition, and regulatory. And typically the type of work they do is they're evaluating and developing new technologies, new equipment, new processes, and new products. And you can see on this page some of the new product innovation that we've released in the past several years. And it's amazing how much technology, engineering, food science goes into developing new products and manufacturing products in a large scale production facility. So the individuals that work in this function, definitely rely a lot on their technical education and background. So then process development is all about developing a manufacturing process and commercializing it. And that's typically done by chemical, biological, or mechanical engineers. It's very process oriented. And if you could imagine the the main ingredients in milk chocolate are sugar, cocoa butter, cocoa powder, liquor, or sorry, and milk. And if you were to just take those raw materials and throw them in a bowl and mix them up, by no means do you have milk chocolate. So there's a lot of processing steps that are required to take those raw materials and receive them in huge quantities and convert them into a finished product. And so that's what the process development team would do, is figure out, what's the most economical way to do that in a very large scale situation. And they work on developing manufacturing processes, defining equipment types, establishing operating parameters and tolerances, developing specifications, and conducting pilot scale testing as part of the scale up process. And there's a lot of engineering calculations that must be done to properly design a process. And now it's time for another question. How many Hershey Kisses does the Hershey Company make in one day in Hershey, Pennsylvania? $70 million, $500 million, $50 million, $2 million, $1 million. I'm seeing lots of different answers. This is great participation, by the way. So it's 70 million per day, which is a lot of Hershey Kisses. That can stretch from New York City to Los Angeles. So there's a lot of people that eat a lot of Hershey Kisses out there. So then there's process design, and that is where typically it involves a much larger cross section of engineering, chemical, biological, mechanical, who typically work on the process equipment. But then we have electrical and controls because there's a lot of automation and sensors in a process, and the control systems. There's civil engineering from the standpoint of building fabrication if we're building a new facility, and mechanical design when it comes to layouts and doing AutoCAD type work. So those are the type of degrees or STEM fields that would work in a process design. And this is a very tedious and detailed job where detailed equipment specifications and control algorithms are designed. As I mentioned, building design and construction, process layouts, installation, and startup is also part of the role when we're putting in a new process and designing a new process. You can see this is just an example of heat transfer calculations that might be done to properly size a heat transfer vessel. And this diagram in the upper right is called a piping and instrumentation diagram that the process engineer will put together, which is really the blueprint of the process and defines and links the control system to the process. So these would go hand in hand because this is a continuous evaporator that's used to make caramel, and you need to do these calculations to properly size it and make sure you're making the product that you want to make. And process optimization is really working very closely in our manufacturing facilities on existing installations to improve their manufacturing process. And once again, it's mostly engineering, but there's also some food scientists and chemists that work in this space knowing relationships between the process and the product. And several of the areas that they might work in would be applying new technology to a manufacturing line, new equipment, increasing the capacity of a production line, reducing waste or variation, adding automation, or using what's called Lean Six Sigma methods, which are statistically based methods to accomplish waste reduction, variation reduction, capacity increases. And then we actually have technical roles in our manufacturing facilities. So we'll have chemical, biological, mechanical engineers, electrical and controls engineers, and food scientists and chemists working in different areas in our manufacturing plants. We have plant engineering staffs that maintain the facilities and the operations, and you'd find these technical STEM backgrounds in quality assurance as well, even biologists. So in just about every facet of the company, you'll find these STEM educations. Project management is really all engineering disciplines and all science degrees could be working in this field. And project managers are really just very well organized, and they're responsible to deliver a project, within budget, within schedule, and ensure that they have all the resources to complete their project, and the project meets all the design requirements. It could be what's called a capital project, which is overseeing the purchase and installation of new equipment or buildings or financial capital. But it can also be just a general project type management, managing innovation projects, IS projects, or we call that information security, but information technology, IT projects, projects to increase capacity, or even change management projects. So now it's time for another question, and I'll pull the chat up so I can see. What brand did Hershey acquire recently? Any guesses on this one? I might have. Oh, look at that! Someone nailed it. Damian Musk. Here we go. Dots Pretzels. You either like to eat Dots Pretzels and recognize them from the picture, or you read the news. So this was one of our more recent acquisitions. Just closed the end of last year. And then we actually have an advanced technology team, and that's mostly engineers, but they work on advanced technology. And this is a photo of a automatic palletizer. You can see there's cartons coming in, and this will put the cartons on a pallet and build a pallet. But they will work on new equipment design. And what's really popular now is machine learning and autonomous manufacturing, and it's called Industry 4.0 in the manufacturing industry, but it has to do with connecting everything to the cloud with respect to a manufacturing process, pulling real-time data and actually letting the cloud algorithms control the production line and learn from all the interrelationships of the data that it receives, which a human can't really discern all those interrelationships. So this is the newest area of where manufacturing is going, is this Industry 4.0 advanced technology, autonomous manufacturing. And data science is another emerging field. This is probably one of the most popular fields, or highest demand degrees. And the typical degrees that employees in this field would be a data analyst, data science, computer science, applied math, statistics, finance, even psychology, because there's a lot of statistics and math in psychology. At Hershey, we have data scientists like throughout the organization in all these different functions, human resources, engineering, finance, marketing, sales, IS and IT has quite a few. So that's really an emerging field that didn't exist, say, 10 years ago. We didn't have careers called data scientists, but heavily STEM oriented career. So just a little bit about STEM and students. Whoops, I am sorry about that. So I always, you know, try to suggest that students embrace STEM, encourage your students to embrace it. Students that typically would have an interest and propensity for math and science. They're naturally analytical, good problem solvers, naturally inquisitive, and have a good work ethic, because typically the STEM educations require a little more work than, say, some of the social sciences. And locally, we have resources that we do educational outreach with local high schools. We do shadow days at the Hershey Company. We have a scholarship that's available. So if anyone's online and is in high school and is in the local area, you can feel free to contact me and I can get you connected with these, although we haven't done a shadow day in several years because of COVID. But so, as I mentioned before, chemical engineers specialize in the conversion of raw materials into finished products. So, you know, these are the three major components. You've got sugar, you've got milk, and this is actually the inside of a cocoa bean. These are what we call the nibs, or the bean. So those are the major components of milk chocolate. And as a process engineer, we know the interactions between these raw materials and the finished product and the process, and how to convert them properly. So, you know, Hans is going to talk a lot about the processing of cocoa beans from the plantation to its what we call in-process materials of either cocoa butter, cocoa powder, or chocolate liquor. And then this would be taking those raw materials with milk and sugar and mixing them and refining them, which is creating a very fine particle size, and then creating your finished liquid chocolate batch in some sort of a mixer that we call a conch. But melted chocolate is actually a suspension of solid particles dispersed in a liquid. So you've got sugar, cocoa, and milk solids in a milk chocolate, and cocoa butter, milk fat, and emulsifiers. These are typically what your milk chocolate is made of in a continuous phase. Liquid above 105 degrees and solid below. And I don't even get into this, but one of the interesting things about the cocoa butter is it's polymorphic. So it will crystallize in multiple shapes of stable cocoa butter crystals. And there's a process we use called tempering, which is taking the liquid chocolate through a sequence of specific temperatures and with shear to create the most stable seed crystals, so that when you cast it into its shape, it will solidify properly, have a nice gloss, a nice snap, melts nicely. So viscosity is a very important principle in chocolate making, and that's really used. It's a physical property of all materials, and it's the resistance to flow. And water has a very low viscosity. It flows very easily. You pour some on the floor and it goes everywhere. Ketchup, honey, and melted chocolate have high viscosities and require energy to get them moving. So depending on what we're manufacturing, we have different viscosity specifications for chocolate. So when we're making a drop kiss on a belt, we have a depositor that takes this chocolate, and as you can imagine, it's very thick, because when it's deposited onto the belt, and it's probably 97% like the fat is probably 97% liquid in this phase, but it's so thick that it just stands up to the point where the tip will stand straight up. And that is what we want for manufacturing a drop kiss. When we manufacture a bar, this is cast into a mold, so you don't want it to be thick. It has to be very low viscosity, so it spreads throughout the mold, and the air bubbles can be removed, and it fills the whole mold nice and evenly, so you get a nice bar. And so we can manipulate the viscosity in chocolate, and the different ways are, temperature will impact viscosity. The amount of temper will affect viscosity, as well as the amount of the fat, the amount of fat, the liquid phase in the dispersion, and also using emulsifiers, which are ionic molecules that will kind of bind the water to the oil to reduce the surface tension between the two and reduce the viscosity. So I kind of covered some of this, but emulsifiers are used in a lot of food products, such as margarine and salad dressings, because it does help keep those immiscible liquids and solids in solution. And in chocolate, one of the most common emulsifiers is soy lecithin. It comes from soybeans, and it helps the solid stay in suspension in the fat phase, and it makes it very flowable. It has about a 10-to-1 effect compared to, say, fat. So for every 10 pounds of cocoa butter we'd have to use, we could put in 1 pound of lecithin and get the same viscosity reducing effect. And the way it works is because there's a fat loving end and a water loving end, and that just binds, helps keep everything in suspension and reduces that surface tension between the, any water that's in the system and the fat. So that was my quick, very quick overview of some of the technical concepts in chocolate manufacturing.
Thank you so much. That was fascinating. And there are definitely some questions we've been collecting on our end. Yeah, so Hans, you are up next.
So let me just start out. My name is Hans Geyer, and I didn't give my kind of educational credentials. I graduated with an undergrad in food engineering from Purdue University, and just last year, in my 50s, I finally got a master's degree in food safety from Michigan State. And I've enjoyed being a learner now so much that I'm pursuing my degree in certified financial planning, which is my next endeavor. So I'm here to talk a little about how chocolate is made and more the part that happens outside of the US. So as you go through this, you can think about what kind of careers are in there, and I'll kind of point out some things when we get to the end. But really what I want to do is have fun and just kind of make you aware of what happens within part of our food chain, or our food supply chain, especially some things that happen outside of the US. So take it away. Next slide then. All right. So this is my background. I worked 15 years for M&M Mars, and I helped set up a number of green site facilities throughout the world. And I worked in Poland, I worked in Brazil, I worked in cocoa and nut processing, chocolate process development, and I really traveled quite a bit for M&M Mars throughout the world. I've been with Hershey 18 years now. I was a process improvement engineer. Then I worked in kind of chocolate and technology and how we make it. And for about the last 12 years, I've been responsible for cocoa, dairy, sugar, fats and oils, and sourcing it and things like that. So that's a little bit about my background. Let's jump right into cocoa. So most people have never seen a cocoa tree. So here's my first question to you. I'm going to ask a lot of questions. Go ahead and slap them into the into the chat your answers. What are the top cocoa producing countries? And a little hint, I blacked out that area. It's got to be 15 degrees north and south of the equator. And why is that? A cocoa tree to grow well likes an average temperature on a year-round basis of 80 degrees. So that's pretty warm. I mean, that's night, day, winter, summer. It likes 80 degrees. So it looks like we've got quite a few people really hammering it. People are naming a lot of origins, a lot of small origins. Cocoa, if we bounce to the next slide, I should have the true answers posted on that next slide. So this is kind of the world's cocoa production there. Right now, 63% comes from those two little countries of Ivory Coast, some people call it Cote d'Ivoire, and Ghana. And really the big one there is Ivory Coast. It produces the majority, around 43% of the world's crop. Ghana produces about 20%. So they're really the workhorses. Right next door, you have Nigeria and Cameroon, which also produce a lot. After that, you jump over to South America, and Brazil produces cocoa. But a lot of people don't realize this. Brazil does not export cocoa. They actually import cocoa because their domestic crop isn't big enough for their internal consumption. So all these countries you can see, they're right around the equator. Now there's a lot of small countries that do a little bit here. So like a Costa Rica, a Madagascar does make some. Somebody put that in the chat. Tanzania, Dominican Republic, Colombia, all those are minor growers, but really the workhorses of the industry are the Ivory Coast, West African area, and then some of the Peru, Ecuadors are coming on. So that's a little bit around how cocoa is, or where we source it within the Hershey Company. Here's a bonus question for you. Hershey is a very large chocolate company. What percent of the world's cocoa crop do you think Hershey ends up in a Hershey product? And when you think about cocoa, it goes a lot of different places. It's not just chocolate. Think about chocolate ice cream. Think about brownies. Think about just everything, donuts, anything that's chocolatey most likely has cocoa in it. So there's a lot of companies that are chocolate companies or use cocoa that you don't think of being cocoa companies. So Krispy Kreme makes chocolate donuts. They're like a chocolate company. So let's see. We got some really good guesses there. On a global basis, Hershey uses 5% of the world's cocoa. So 1 out of every 20 cocoa beans ends up in a Hershey product in some format. So that's kind of an area of how kind of the scale that Hershey has. And most of our business is in the US, so really about 4.8% of that 5% is in the US. So we're really big there. So cocoa. One thing that's unique about cocoa, the flower is actually right up against the tree itself. And the reason why the flower is on the tree is because that's where the cocoa pod forms. And cocoa pods are heavy. These are big pieces. They got like 60 to 100 beans in there. And they can weigh pounds. So if you had a cocoa pod at the end of your branch, it would actually break the branch. So they grow right up on the tree. It takes about 180 days for a cocoa pod to develop, and a tree will give you about 60 pods per tree. And that's a good tree. I won't ask you this question because it's too technical, but this Diptera xerica something or other, I can't pronounce it. That's actually the insect that pollinates cocoa, because you need pollination in order to form the pod. So that's a little bit about the tree itself. Another thing that's unique about cocoa is it actually gives fruit throughout the entire year. So in West Africa, there's a main harvest, which is really October, November, December timing. But then there's another harvest that's more like June, July, August. But in between those two harvests, it continues to put off pods, just not very many. So it's not like an apple tree where you get like one harvest a year. It can produce throughout the entire year, which is interesting because you can always kind of have pods coming off. All right, next slide. So here's some of the typical types of cocoa that are out there. And really the three that are the Criollo, the Trinitario, and the Nacional, those are small. Those are like 5% of the world's cocoa crop. The big one is the Forastero, which is up in the upper left corner, sorry, upper right corner. The reason why that's the most popular one is, quite frankly, it yields the best. So the farmer makes the most money. And it also has the flavor that people would recognize as chocolate. So almost all the cocoa that you would have in a product would be Forastero. And that's what's growing in Africa and Brazil and Ecuador and everything else. So here's a bonus question for you. What classic soda bottle is based off the shape of a cocoa pod? Oh man, Damien, we're gonna have to X you off here. Some other people got it too. Very good. So rumor has it, if you have STEM skills, you might do research to figure this one out. But Coke, when they were rich, most people know that Coke was originally had cocaine in it. And they transitioned it from like a cocaine-based material to a soft drink without the cocaine. The original shape of the bottle, they went and they looked at coca areas, and they actually picked a cocoa pod to help shape their bottle. It sounds like coca, but it's not. So that's just an interesting tidbit for you. The actual shape of the Coca-Cola bottle comes from a cocoa pod. So here's another question for you. This is what we call a cut test. This is how we evaluate the quality of cocoa beans. So we chop them in half and we look at the color. So here's a question for you. What color is a cocoa bean when it's first harvested, when it's fresh? And you cut it open. All right, we're getting some answers in there. Nobody's got the right answer yet. You got to think a little bit outside of the box on this one, maybe. All right, and let's see the next slide, and everybody will get it. Oh, Damien got the right one there. Purple. They are bright purple, almost like the bright purple of a purple cabbage plant. And that's because it's loaded with anthocyanins, and a lot of really healthy polyphenols are in the product. I actually have a number of patents going back to my days with Mars when we were patenting the health benefits of kind of raw cocoa and all these polyphenols that were in there. So it's purple. But if you eat that purple product, oh my gosh, it is so bad tasting. You would not recognize it as cocoa that you eat. So now we're going to go into what happens to change it from this purple material to actually something you recognize as more of a chocolate flavor. So, okay, next slide, please. So what we do, the first step in origin is actually to break open the pod. And those are pods. You can see in the upper left, the beans are actually covered with pulp. That pulp really tastes good. It's kind of like a real sweet, fruity flavor. That's all I can describe it as, because there's no other fruit that I've eaten that would really compare to the sweet, fruity flavor. Those are actually good to kind of suck on and chew on and eat, but you don't want to eat the actual bean itself. So these are all broken open, generally out in the field or in the plantation area, and then they're put into some kind of container. So you get a bunch of these beans, and they're covered with all this sweet, pulpy mass. So the pulp creates them. And if you flip to the next picture, the next thing we do is fermentation, and it's actually a controlled rotting, is how I would explain it. You grab all these beans, and I'll show you how it's done. But the key is, like, you got all this sweet, gooey pulp on the outside, and you need to get rid of that. And if you don't get rid of it, it's hard to process your cocoa. It's hard to take the shell off. So as the product ferments in this heap, which I'll show you in a moment, the actual bean dies and polyphenol oxidase reacts, and that starts reducing a lot of the bitterness. So it's actually the beans dying, and you reduce the astringency by the polyphenol oxidase. At the same time, there's other reactions that go on that create these aromatic flavors. There's fruity flavors, winey flavors. And at the same time, some of the chocolate precursors form in the form of proteins. And if they do this step wrong, then we get bad flavors. Think of things like hammy, fishy, ammonia, earthy, moldy. So if it's not quite done right, or if it goes out of control, you can get these bad flavors. And then the final thing is it actually increases the content, the fat content, because you ferment carbohydrates. All right, next slide. So this is actually in Africa. and they have banana leaves. So they make kind of like an umbrella on the ground of banana leaves, and then they'll pour the mass of cocoa on there. So we're going kind of top left to top right. They've poured the mass of cocoa in there. And what happens is they think about a fermentation, you got a microbe somewhere. What they've done is studies have actually shown it's the hands of the workers that actually inoculate the cocoa beans to start that fermentation reaction. They then cover the heap with banana leaves, and that's what you see down there in the left corner, and they kind of pile it together in banana leaves, so it's kind of like this pile of banana leaves with the cocoa in the middle, and that kind of helps hold in the heat, and they ferment it that way for 3 days. And then they open that heap up. Oh, go back. Stay there. We got some other techniques we'll talk about. They open it up and then they turn it over, and that's kind of like stirring the pot. Fermentation will get a lot hotter in the center, so they want to move the beans around so some of them aren't to get the same level, so that it's kind of like a homogeneous type of fermentation. All right, and this is actually what our gold standard is for how we like to see cocoa processed, with banana leaves and a pile rotting in the jungle. And countries like the Ivory Coast, Ghana, Nigeria, this is how they do it. All right, next one. Some other origins where there's bigger places, they actually bring the wet beans in and they stick the wet beans into these boxes. And some of them are set up so that, let's say there's 4 boxes. Every day, the cocoa will move from one box, starting at the top, down to the next, down to the next, down to the next. And during that time, when they move from one box to the next, the whole thing gets kind of mixed around so that it helps the fermentation process be even. And you can see here the fermentation process, you're seeing the carbon dioxide coming off as the sugar ferments away. There's a lot of inoculation that goes on here, because you can see people standing on the cocoa beans and helping kick them from one box to the next. This is common in origins. This is what happens, but this would happen more in like Brazil, Papua New Guinea. The Dominican Republic has a lot of fermentaries like this where they make specialty products, and Mexico has some places where they do this. So this is what we call box fermentation. And it tends to make a very sour product because it's over fermented. So you get a lot more of the acetic acid forming. So it's more of a sour cocoa. All right, next slide. And then there's other things where small places, some origins don't really ferment. They'll just throw it into bags, and they'll just kind of rot in the bags or ferment in the bags. Other places will have small vats. And in Mexico, they make a product called lavado, which means washing. And they actually just wash the pulp off and they just throw it out to dry. Those beans are really bitter and astringent, and you really won't want to make a chocolate out of them. You can use them as a component, but they're just really bitter and astringent. Okay, on to our next slide. So that's a little about fermentation. It's really important. So here's the actual colors of the beans, and this is how we evaluate fermentation. So slaty is just not fermented at all. It's actually a defective bean, and those taste incredibly bitter. The next phase is purple. Reminds you of how that fresh bean looks. They really haven't been fermented. That's how a lavado bean would look. These beans were actually in Ecuador from a trip that I took down there 2 years ago. What we like to see is purple, brown, and brown more so, because brown is well fermented, and those are going to give you really good chocolate flavor. So that's a little bit about how we evaluate fermentation. There's all kinds of fancy methods, but at the end of the day, this is what the industry uses. Next slide. So once they're dried, once they're fermented, they need to be dried. And the way we do this is by just stretching them out in the sun and allowing the sun to dry them. Cocoa needs to get down to 8% moisture to prevent things like mold from growing, to deactivate some of the enzymes, which would create some negative reactions in the beans. So we like to see it less than 8%. And once it's below that, it can stop drying. So next slide. That's sun drying. That's what we really like, because it allows some of those acids to volatilize. So you get a really pleasant tasting cocoa. Other places where it's too rainy and not enough sun, we'll actually dry it using mechanical dryers, very similar to grain dryers that American farmers would use for corn or soybean. In this situation, the interesting thing is that it locks in a lot of the sour flavor when you use these techniques. All right, next slide. So this is something we don't like to see happen. Some places will actually burn wood, and that wood and smoke go into the dryer, and then the beans get a smoky flavor, which is a defect. I don't want to talk poorly about other or some manufacturers' products, but some origins like Papua New Guinea and Brazil use a lot of that type of beans. So Papua New Guinea, because it's on the Ghirardelli, because they're on the West Coast, they'll bring in Papua New Guinea beans and use those in their formulation. And when I taste their baking chips and their dark chocolate squares, you get some of that smokiness and some of the sourness from the Papua New Guinea beans. But that's what their consumers like, so they're making a product that's good. All right, next slide. So I'm kind of at the end of my time on this. Kim, how am I doing on time overall?
Yeah, you're doing fine. Let's probably just go over a few minutes on questions, but you're doing good.
Before I talk about careers in the food industry, of which Lou's covered some of it already, are there any questions that people have that they'd like to ask about chocolate or cocoa or things of that nature? I'm really good at making stuff up, by the way.
Oh, sweet.
If you can stump me.
Actually, one that came up that actually is really interesting is kind of, do you know, when you talk about the fermentation of the cocoa, what bacteria is it? Do we know what microbes it is?
Absolutely not.
Okay.
So it is so I will give you an interesting story on that. There was a company. So you think about like wine, and oops, this is high school students, but I guess it's food science. So in wine or cheese making, you might use very specific cultures to start. Or wine, you use a very specific bacteria. Beer, you might use so anything you're fermenting, you might use a very specific bacteria. They tried to do that in cocoa. It made a very specific flavor that did not work well for us. So what the bacteria they actually found that are doing the fermentation, whatever was on the person cutting it open's hands, that's what goes into the fermentation. So
Awesome.
There's no magic there.
No,
I mean,
that was
whatever's on the banana leaf, whatever's on the stick they're hitting it with, whatever's in the bin, they've tried to control it, but haven't been able to have that same success like you have with cheese, wine, beer, other fermented products. Can we grow cocoa at home? So in Hershey, Pennsylvania, put a plug in for Hershey. We have Hershey Chocolate World, and occasionally, well, you will see flowers. Number one, they have cocoa trees in Chocolate World. You will see flowers on the trees. I've never seen a full-grown pod, but you will get the real teeny tiny pods that are maybe an inch long. I've never seen one fully mature. Probably not enough humidity or something of that nature, or maybe not the right bugs, or I guess they would be bugs because you won't get a pod otherwise. But yeah, really hard to grow cocoa at home. You can actually grow a plant at home, but you'll never get a pod on it. Actually, Penn State, and I'll put being from Pennsylvania, Penn State is probably the leading kind of chocolate school in the U.S. And they do genetic works and things like that on how to reproduce cocoa plants and things of that nature.
All right, they're doing some other very interesting crop stuff over there.
Yeah. Any other questions on cocoa?
The last one, I think, actually, or I have to double check here too. Hold on. How much polyphenol is retained kind of like at the end of the cocoa processing? Like when you get a dried bean? So
let's not go dried bean. Let's go all the way to
chocolate.
Yeah, let's go to dark chocolate.
Okay.
So of the liquor, which is the product that contains the cocoa that goes in there, on average, it's probably like 30 to 35% would be retained. So there's a huge chunk that's lost during fermentation. So the more you ferment, the lower it goes. And then when you roast it, roasting is an oxidation reaction. So roasting will take it down. And then your next step is if you combine it with certain things that have free radicals, then they'll start quenching that and it'll take it down even further. So as you make a milk chocolate compared to a dark chocolate, the milk interacts with it and binds it. So they kind of all go down. It all depends on how you measure it also. But generally, the way I look at it is anything that makes it taste good reduces it. So that's kind of, unfortunately, that's one of the things. If you want to get healthy stuff, you got to learn to eat it raw.
Awesome. And then you want to finish up your slides, then we'll get Lou back on and ask some more questions.
Yeah. So Lou pointed out a lot of these things here, a lot of the different careers, and I think for me the most important thing when I think about what STEM careers, and a STEM, I'll even just say a STEM education, it really teaches you to think in a very kind of logical, scientific manner. And I think that's what carries over into your career and how you think about things and how you evaluate opportunities and where you go, because you're using kind of some of those same fundamentals that you learned during school of researching, investigating, being inquisitive. So Kim, if you could flip the slide here. So Purdue engineers, there's a number of Purdue engineers that work at Hershey, and I'm an agricultural engineer, and I am the only Purdue engineer doing what I consider, well, I shouldn't tell you that. The next person does a technical thing, but I'm probably closest to engineering of any of the Purdue engineers. And I'm working with engineering principles and science principles. I have a colleague that I went to school with. He's actually in our data analytics area, and he does data analytics. He started more on the sensory side, where there's a ton of data analytics, and he's migrated to the human resources side doing data analytics. So he was a food engineer. He learned how to make food at Purdue with me, and now he's in analytics. Chemical engineer, our chief procurement officer, so the person who's responsible for all the people that buy all the stuff. And buying is a big thing as a company, because you always got to buy all your raw materials, even your marketing, advertisements, things of that nature. Really big job. That person's a chemical engineer at Hershey. And then another person that buys all of our media, he's a chemical engineer from Purdue. And that's a totally different skill in working with media buying. You understand impressions and how to get that message out there, and how to work through the decisions in that area. Once again, your STEM education pays off. And then the one that I just find absolutely crazy is our chief growth officer for a consumer product company like Hershey. This is one of the most powerful positions in the company. Like, I think on the org chart, they're like number 3 type of thing. She's a mechanical engineer from Purdue. And I think she was also a professional engineer. So it's just crazy for me to think, like, these are all the engineers at Hershey. I'm the only one doing things technical. So when you think about careers, don't limit yourself to like, oh, I need to be in a science or lab or, designing something. There's all these other areas where you can apply sound science and those skills you learn via STEM education. So that's my little poll, is that technical degrees open doors. And I think that was my last slide.
And unmute myself. Let's get Lou back and get through some questions. And kind of keeping on trend, can you guys talk a little bit about, how, like, when you talk about these processes, how applicable are they to other industries? What other industries are off the top of your head?
I think there's a lot of processes within confectionery manufacturing that are translatable to other totally unrelated products. We use evaporation, crystallization, heat transfer, fluid dynamics. So some of the basic on a process side, from that respect, they're translatable. What I found interesting, I toured one of our local newspapers when they were printing newspapers, and the pumps they used to pump their ink were the same pumps that we use to pump our chocolate, because from a viscosity and they're a suspension of, pigments in a fluid, it's all the same. So it's really interesting when you look at that. So yes, very translatable.
Mm-hmm.
Hans, you might,
Yeah, my answer is like a little bit different. So if you're saying like how do these cocoa and chocolate and confectionery skills translate to the rest of the food industry, I really focus in on a lot of the quality aspects of food. You know, like all food companies have to have their quality programs the government mandates, and we have to meet them. And most companies, like big branded companies, we go way beyond that. So regardless of what's going on in food, you have to have a validated kill step, which means if there's any pathogens, you got to figure out how to knock them out. You know, things like what's food safe, you know, like think about like contaminants that can be in the products, toxicology, nutrients is a huge area. So all this stuff is things that I kind of have to worry about. Like when I'm thinking about like cocoa, it's like, okay, does that cocoa contain lead? Because lead is really bad for humans. So how do we take it down? Those kind of things are generally what you look at throughout the entire kind of food chain for quality, and those apply across whatever food you're making. You know, it just looks a little bit different if you're making dairy versus, you know, raw vegetables, versus
My
chocolate.
dad is a dairy guy.
Yeah, so dairy, you know, dairy, it's very regulated and there's very specific pasteurization projects, and that's, you know, pasteurization, Pasteur, you know, kind of that's where it all started. But those kind of food safety skills really translate across all of it. And then the other, I mean, aside from that, like the part that I really enjoy about my job is not the part that's translatable. It's the part where you sit down and say, hey, I'm an expert. I'm going to taste this and figure out like whether it's good or not. So sometimes it's like some of those niche things you get to do that are a lot more fun than the translatable stuff. The translatable stuff tends to be more like bog standard, and the things that are really fun are kind of these niche areas you get to play in.
Awesome. So can you actually both speak a little bit more about kind of like where you're seeing some of these like new jobs like data science and like automation really like coming into full force?
I think, you know, data science is everywhere, and you know, even in non-manufacturing industries, data science is big. It's big in marketing, always trying to, you know, you look at all the consumer information that all these social media websites collect on you, and Google, and you know, so data science is huge, I think, just in any business, and in any manufacturing facility, that's really staying on top of the technology, and where, you know, making sure that they're going to be ready to be one of the most efficient manufacturers in their business. They are investing in what I call smart manufacturing, or in Industry 4.0. Some of the smaller mom and pop, you know, family owned businesses might not be doing that, but you know, it's going to be across any manufacturing industry, all manufacturing industries that'll be looking into Industry 4.0, smart manufacturing, autonomous manufacturing, because that's the wave of the future.
Yeah, I couldn't agree more with what Lou's saying, but this is kind of, this is a take-home piece that I would have people think about. Like everybody here's gone into a grocery store and seen like, oh man, one of my favorite products isn't there, right? It's happening everywhere. And one of the big reasons for that is that we don't have people showing up for work to actually make part of the product that's that's critical in making something. We have run out of so many things over the past 2 years because the supply chain is just broken. And one of the pieces, it's heavily human dependent. And what I see happening is that one of the reasons inflation is going up, because wages are really increasing. And how does this refer back to technology? Technology is the answer that the US uses to bring down our costs. So we put a technology solution on it. So you think about like, well, what can we automate? You know, at one time people were hand wrapping kisses. You know, when Milton made that first kiss, it got hand wrapped. We are now wrapping kisses at 800 to 1,000 a minute on a machine. And it's crazy. And that's the kind of thing that's constantly happening as labor costs go up, which there's natural tendencies to drive labor up because we all want a higher standard of living. The way you push back is better technologies to automate things. It's office work, it's production work, it's the whole 9 yards. Like when you go into a factory at Hershey, there might be 3 people running a line that makes 100,000 pounds in 8 hours. And that's the kind of automation that's just going to continue. So it's not only, it's the people developing the equipment, it's people maintaining the equipment, it's the people putting in the equipment, and that trend's just going to continue.
Awesome. No, that's a great answer. And I've had other people do manufacturing kind of talk. It's a lot of that stuff, right? Is just like, how are we making things faster? And then I need to share a slide, and I have one more question for both of you. So there's my share. I just want to thank everyone for joining us. Before I ask the last question, Michelle is going to put in our next Square Root of STEM, which will be in 4 weeks? Yeah, 4 weeks, I can do math. And it is about bio-inspired adhesives. And to wrap this whole thing up, could you guys tell me what's your favorite Hershey product?
Oh, I don't have a favorite Hershey product. I love them all. I'd say, okay, Reese's, since I'm wearing a Reese's garb.
That's mine too.
So for me, I tend to eat all the time. So this is the way I control it. I pick out a favorite candy of the month, and we have candy bowls throughout our office building, and I only eat when I see that candy piece. And I usually like kind of weird stuff like dark Kit Kats or white Kit Kats or things of that nature. So that's kind of how I do it. It's like I pick out a really obscure candy that I like dark Kit Kats or white Kit Kats, and then I only eat those, and I only eat them when I see them. So yeah.
I'm hearing Kit Kats though.
Yeah, not the normal ones, but the specialty ones. But I think the big thing that I do is like there's certain raw materials that I will just eat, like the peanut butter that goes into Reese's peanut butter cups. I won't eat the cup, but I will just eat that peanut butter. It's so good.
What's this month's favorite then?
Well, unfortunately, they kind of took away those candy balls. So this month's favorite is whatever somebody has in my office. And I've actually gotten really crazy about some of the things. So I have a lot of cocoa mass, which is just ground up cocoa beans. It's like, we call it cocoa liquor. It's basically, it looks like chocolate, except it's pure liquor, incredibly bitter and astringent. I'll even eat that when I get hungry at work. Just start throwing it down, and it's kind of a unique
nasty
taste. Yeah, but you know, you got to learn to love it. It's the healthy stuff.
Awesome. Thank you, Hans, and thank you, Lou, for speaking with us today. I have to say, a lot of comments in the chat about how they did not know how interesting chocolate could be. So thank you both for presenting. I also want to thank our sponsors, which are the Better Them Foundation, Virginia Department of Higher Education, Illumina BAE Systems, Broadmoor Charitable Foundation, Akamai Technologies, Aerojet, Rocketdyne, Equitrans, Midstream, Jacobs Engineering, Lockheed Martin, and TC Energy Foundation.